This is Unit 1, Lesson 4, exploring transformations of quadratic functions. So our learning goal today is understanding how the parameters a, h, and k in the function f of x equals a x minus h squared plus k affect and change the graph of f of x equals x squared. So this is going to be something that we're going to use obviously in this unit, but also in units to come. So we're definitely going to need to be familiar with this formula here and the content of this lesson. So before we get into the actual lesson, we're just going to define a couple things to get us started. So transformations, we're simply going to define as alterations made to the graph of f of x equals x squared. So f of x equals squared is something that we're going to call the base function. And then you can see in that formula that I underlined, all we've done is we've added a, h, and k to that original function of x squared, and those parameters are going to obviously make alterations to the graph or transformations. The other definition that we're going to need to know is congruent. And to make this very simple, we're just going to define this for our case, for this lesson, as having the same slope. Just to make it easier. Congruent obviously is going to mean different things based on the context, but for this, we're just going to think about it as having the same slope. Okay, so we're going to fill in the following tables. We're not going to use a graphing calculator. So in this table, for f of x equals a x minus h squared plus k, a is going to equal 1 and h is going to equal 0. So we're just working with k here. Okay, so basically what this lesson does is we're going to break down each part of this function separately so that we know what is changing in each case. Okay, so we can see our base function here is f of x equals x squared. So when f of x equals x squared, the value of k is obviously 0, right? We don't have a value for k. The direction of opening is up. So if you were to graph this function, which we will in the future, but I'm just going to draw you a little bit of a graph over here. Let me make it nice with nice straight lines. So the function, and this isn't going to be perfect, but the function x squared makes this parabola, that wasn't too bad, that crosses the origin, okay? Because it's a positive x squared, we know the direction of opening is up. The only way the parabola would be opening down is if there was a negative out front of the x, and we'll get into that. Okay, so the vertex of this function is at 0, 0, as you can see kind of from my drawing there. The axis of symmetry. So the axis of symmetry is going to be that middle point where both sides look the same. So I don't have a dotted line. So if I drew this perfectly, which I didn't, that pink line would represent kind of our axis of symmetry. So both the left side and the right side are the same. And the last part says, is this congruent to f of x equals x squared? Well, this is f of x equals x squared. So obviously, yes, it's congruent, which means, again, it has the same slope. So the same value in front of x. And this one obviously does because 1 is going to be our a value, which is the value in front of x, which represents the slope. And all of these are going to have the same slope. Okay, so they're all going to be congruent. Okay, so now let's look at f of x plus 2. So the value of k in this is obviously 2, right? In the function f of x equals x squared plus 2. And like I said, the direction of opening is still going to be up because it's a positive x squared. Our vertex. So our vertex is actually going to shift. So our vertex is no longer 0, 0. It's actually 0, 2. And our axis of symmetry is going to stay the same. So I'm just going to fill all of this in. This is all going to be x equals 0, x equals 0, x equals 0. Okay, and like I said, it's always going to be congruent to x squared because our a value isn't changing. Our slope is not changing. We're simply shifting that graph up and down, which we will get to. And if we used a graphing calculator here, or if you have a graphing calculator, or if you want to pull one up on the internet and actually do this investigation, you'll be able to see all of these things. So this is all just going to be yes. Okay, and like I said, the direction of opening is always going to be up because those are all positive numbers. So I can fill that in as well. Okay, so there's really only 2 things that are changing here. So we can basically ignore those 3 columns and just focus on the 2 that I'm going to underline here. Okay, so now let's move down here. So the value of k in this next function is obviously 4. Okay, and our vertex is going to shift then to 0, 4. All right, the value of k in our next one is -1, which is going to shift our vertex to 0, -1. And I'm sure you're seeing a trend here. Lastly, our k value is -3, which means our vertex is 0, -3. Okay, so let's think about this a little. If I were to just kind of sketch these graphs, so I'll just sketch a couple. So I'll do x squared plus 2. That graph is going to look something like this. Again, bear with me. Not going to be perfect. Okay, so you can see I drew a graph that its axis of symmetry is the same. It has the same slope. Okay, it has the exact same shape, and it's still opening up. What you can see is that my vertex or my origin has moved up too. Okay, so basically think about this as just the same shape, the same parabola, just moving up or down. Okay, so if I were to draw new color here, x squared minus 1, it's the exact same graph that I would argue is actually -3 because I just drew it kind of weird. Just erase that one. Perfect. So we can see that that is, again, the same shape. It's just shifted down to -3. So this, you didn't have to copy down that chart, but you're definitely going to want to copy down this little summary here. So changing k simply moves the f of x equals x squared parabola up or down. Up or down. Okay, and you might want to draw that graph for yourself just to give you kind of a reminder. So if k is greater than 0, the graph is vertically shifted up k units. Okay, so that's like the yellow graph I drew there. K was 2, so I shifted up 2 units. If k is less than 0, the graph is going to be vertically shifted down k units. And this can be represented with that purple graph, right? My k value was -3, so I moved down 3. Okay, so this one's pretty simple. So k moves the function up or down. If k is greater than 0, we're moving up. If k is less than 0, we're moving down. So make sure you have that copied down. That's going to be very important. Okay, the next thing we're going to look at is how h affects our f of x squared graph. Okay, so again, we're starting with that same base graph, and we're just making changes. Okay, so in this table, in our function, a is going to equal 1 and k is going to equal 0. So we are altering h. So you can see we have our normal function here, or our base function, f of x equals x squared. This information is the same as above. So now we're going to see how h affects our graph. So we see the next one is x minus 2 squared. So the value of h in f of x equals x minus h squared is actually just 2. Okay, you're going to make a side note for yourself here. Keep in mind that the equation itself has the form x minus h. Okay, that negative sign is really important. Okay, I wrote in that the value of h here is positive 2. I did not write that it was negative 2, because if I sub positive 2 into this equation, so h equals 2, in my equation, it's going to look the opposite. It's going to say x minus 2. If my value for h is negative 2, this is actually going to say x plus 2. Okay, and the reason for that is because it's actually x minus, and then I'm replacing h with negative 2. So that double negative will show up as a positive number. Okay, this is going to be very, very important. If you don't remember this, your transformations are going to be off. Okay, so moving on to that next column, direction of opening. As we can see, the a value again is not changing. It's still positive. So these are all just going to be up. Okay, nothing's going to change there. Our vertex. Okay, our vertex is going to change, so we're going to do those one by one. So let's look at that first column. So x minus 2 squared. Okay, before, when we were looking at k, our vertex was 0, 2. Now that we're looking at h, our vertex here is going to be actually 2, 0. Okay, if our vertex is at 2, 0, our axis of symmetry is also going to change. Instead of x equals 0, for this one, x is actually going to equal 2. Okay, and I will draw this in a little graph in a second. And again, the a value here is not changing. Our slope is not changing. So these are all going to be congruent. Okay, now let me pause and draw you a little graph again. Okay, so our original graph looks something like this, as we know. Okay, and this time we are dealing with h. So if we look at this first one, x minus 2 squared. So it's telling us that when our h value is 2, our vertex is going to change to 2, 0. So that means my new graph, yellow again, my vertex is at 2, 0. That means x is 2, y is 0. So my new graph is going to look something like this. Okay, everything else is the same except my vertex changes. I'm actually moving over to the left 2. So my axis of symmetry is also going to change, right? My first axis of symmetry, oops, not perfect, was on the y-axis. My new axis of symmetry is going to go through x equals 2. So let's look at the other ones here. So I have x minus 4. Remember, although that shows as a negative, it's actually positive because what I showed you on the left here. So we have, oops, it's very small. Okay, so in this case, h is equal to 4. Our vertex, again, you're going to see a trend here, is going to become 4, 0, which means our axis of symmetry is now going to be x equals 4. Okay, and again, you can see a pattern, right? Again, be careful with this negative positive situation. So our h value in this next one is actually negative 2. And again, that's because when I sub it into my equation already says x minus h. So when I sub in a negative, as I did here, that actually is going to become, it's going to look like plus 2. So my h value is negative 2, which means my vertex is going to be negative 2, 0. And my x is going to be negative 2. Okay, and I will draw that one for you as well. So if my vertex is at negative 2, 0, that's going to be about here on my graph. So that's my new origin. Everything else about my graph is going to stay the same. Okay, obviously if that's my origin, my axis of symmetry is going to move over. So my axis of symmetry is x equals negative 2. Okay, and the last one here, again, it says positive 4. That means my value that I subbed in was negative 4, which means my vertex is at negative 4, 0, and my axis of symmetry is x equals negative 4. Okay, so again, copying down this summary here so you know what's going on. Okay, so this is for h. So changing the value of h, obviously you can see based on my graphs there, it causes a horizontal shift left or right. Left/right. So if we have x minus h, okay, in our equation, then the shift is going to be to the right. Okay, and the reason for that is because that number is actually positive, right? So you can see that that's represented by our yellow graph here. We shifted to the right because our h value was positive 2. If in our equation it shows up as x plus h, our shift is actually going to be to the left. And again, that's because that's actually a negative h value. So this can be represented by that purple graph there. Okay, I'm going to pause the video here. So this will be a 2-part lesson.